Hi, my name is Ahmed Abdullah. I did this presentation about composite bridges with Ali Abdurrada, Yahya Nazar, and Mahmoud Nazar. What are composite bridges? Composite means that the steel structure of a bridge is fixed to the concrete structure of the deck, so that the steel and concrete act together, so reducing deflection and increasing strength. This is done using shear connectors fixed to the steel beams and then embedded in the concrete. Shear connectors can be welded on, perhaps using stud welder, or better still on export work by fixing and bolts. Shear connectors, correctly spaced to resist the loads, make the concrete work compositely with the steel. Usually steel carries its own weight and that of the wet concrete. But when the concrete is cured and has acquired its full strength, then all future loads like traffic, surfacing, wind, water, pressure, seismic loads are shared by the steel concrete composite. The concrete is good in compression, while the steel good in tension and compression. This composite bridge design can be used in the following ways. Now the first way is a simple beam bridges. On short spans 8 meter, 10 meter, 15 meter and then move expansively up to 24 meters. Bridges can be made from a number of beams under the roadway straight across the gap. The bridges benefits the most from composite action. Over truss bridges. These are similar to simple beam bridges, but for longer spans, from say 18 meters up to approx 100 meters. The deck is still on top of the steel structure, so goes into compression when deflected. Transoms on any type of bridge. Transoms go from side to side across the bridge and carry the deck loads to strong steel frames on either sides. This is usually on open top through truss bridges or closed top through truss bridges. The transoms bend down under load and the concrete contributes the compression strength. Decking. In a normal steel building, the concrete can act together with the steel decking. The steel decking taking the place of the regular steel reinforcing bars within the concrete. However, in a bridge, the underside of the decking is liable to corrode over time, so it is not counted as part of the reinforcements. It is just used to lost form work. Now we have the steel concrete composite bridges. What are the steel concrete composite bridges? Are used as an alternative to concrete bridges because of their ability to adapt their geometry to design constraints and the possibility of reusing some of the materials in the structure. We have discussed the design, behavior, optimization, construction processes, maintenance, impact assessments, and decision-making techniques of steel concrete composite bridges to arrive at a complete design approach. In addition to qualitative analysis, multi-alternative analysis is used to identify knowledge gaps related to bridge design and detect strengths in research. Now we have the advantages of steel concrete composite bridges. The construction process of the SCCP is unique because the construction has a differentiation between the steel and concrete parts of the structure. The most common process is to build and place the steel part first using support system to reduce the deflection of the steel part of the bridge. Then the concrete slab work formwork and the reinforcements are placed and the concrete is poured. This unique procedure gives the structure a characteristic behavior, and researchers are currently developing and studying different construction processes for SCCP. The construction processes can be summarized as continuous precast girder bridges. Now we have girder bridges. Girder bridges are the simplest bridge type of structure and consist of steel beams shaped to an I-section or box section called a plate girder bridge or a box girder bridge. Girder bridges are comprised of deck slabs on which vehicle and people pass, of main girders supporting the deck slabs. Deck slabs include RC deck slabs, steel deck slabs, composite deck slabs, and PC deck slabs. Bridges where the deck slabs and the main girder work together to resist loads are called composite girder bridges, and a bridge designed to resist loads with the main girder only are called non-composite girder bridges. In general, effective spans of about 25 to 115 50 meters are applied, but the Costa e Silva Bridge in Brazil was built with the longest effective span of 300 meters. JFE Engineering has the most experience in the manufacture and construction of bridges of this type. Thank you for listening.